Good morning to distinguished panel members. My name is Kiran Kumar Velala, and I'm currently working as Assistant Professor in the Department of Data Engineering in MEGR College of Engineering. It is my privilege to present our research paper in International Conferences on Digital Technology Driven Engineering 2025, titled Envision Financially Resilient of Households Using High Impact Machine Learning Models, along with the team Dr. Saragadam Sridhar, Dr. I.S. Siva, Dr. P.S. Brahmanandam. Coming to the abstract, as we all are aware of that how COVID-19 has affected several lives globally, we know that. And today, in our paper, we are going to observe that how it has affected many lives globally, and we have considered the Malaysian households to observe that how the effect on the households of Malaysian people has been affected, as well as by considering many machine learning models. We have developed a kind of a model that needs to show that how we are going to overcome the problem in order to make the lives of the people financially stable. And in this, we have taken, we have considered the machine learning models which were developed using the dataset from the special survey on the economics effects of COVID-19. And here we have used 5 predictive algorithms like the gradient boosted tree, as well as the naive-bayes classification, the decision tree, and many more. And we have demonstrated the machine learning that which can reliably predict this household financial vulnerability, which offers valuable guidance for designing more precise and effective future economic stimulus measures. And while going with the introduction, as we have observed that the effect of COVID-19, which was disrupted the economy, leaving many people, as well as the Malaysian households across the globe, which have made them financially unstable, and we have come across some sort of income groups in Malaysia, as well as we have observed that how they have struggled to maintain the financial stability due to their job losses, and their income has been reduced. So for this, the government has introduced several stimulus packages to ease this burden and effectively targeting the households most affected remain as a challenge. And several surveys has been conducted by the Department of Statistics Malaysia, which has provided valuable insights into household employment, their income and spending during the pandemic. Using this data, our study aims to analyze households' financial attentiveness and build machine learning models capable of predicting which households are financially vulnerable. Moving on to the literature survey, we have considered several literature we have gone through. We have done several huge literature survey, but among those, we have considered only few over here as of for today, that which we have incorporated in our PPT, ensuring that these surveys that which was done by one of the survey that which was done by Sangvi, which compared multiple classification algorithms such as decision trees, support vector machines, random forests, and neural networks on census data, and found that the model accuracy, which depends on sensitivity, specificity, as well as predicting income categories. And the other survey, which uses data mining techniques to predict the e-government service rankings across 192 countries. And the other survey, which has proposed a data-driven analytical framework for teaching digital technology programs. And also we have considered another kind of a survey by Locus and his team, which has developed a machine learning approach using government data to predict vulnerability during economic crisis. And moving on to the system design. At beginning, what we have and what we need to do is that we need to do loading the data and exploring it. The dataset which has required and the required Python libraries are loaded, which contains the household and the features of the household, such as we have considered the region, income, food, expenditure, and the target variable is savings. And the data visualization which we have considered over here is a bar chart, which is generated to show the distribution of households with the savings versus non-savings, that which provides an initial understanding of class balance. Coming to the data pre-processing, as we know that the importance of pre-processing, as we whenever we consider the data set, we need to pre-process the data in order to ensure that there are no kind of missing values or redundant data. So here we have considered the data pre-processing by going through by observing whether any missing values. If there are, so means we have replaced with the mean values. And moving on, data normalization, a standard scalar is applied to normalize all the features that which we considered over here in our data set. And the data splitting, where the data set has been divided into 80% is training and 20% is testing data to evaluate our model. And coming with the model training, multiple algorithms are trained over here, like decision tree, random forest, naive Bayes, MLP neural network, gradient boosting, and extended ADA boost. Our model, which has evaluated the accuracy, precision, and we have calculated the FI score, and we have measured the confusion matrix, and the comparison of performance have been observed via through bar charts and comparison tables, which summarizes excuse me, and compare performance across all algorithms. And here it was observed that the best model selection, whereas we have observed the extended ADA boost, which has been identified as the highest performing model based on accuracy and other metrics. Moving on to the system architecture, the architecture which resembles that how these machine learning models are going to predict the financial vigilance among households, where we have developed a kind of a machine learning models for predicting this financial vigilance. And we need to understand the data set we have considered that which affected many people during COVID-19. And we have gone through the DOSM survey that which has collected more than near about 2 lakhs respondents, and we have considered 43 variables over here, and the data preparation that which was done by considering the raw data and converting it into structured data by handling the missing values, preparing the data as per the requirements of our machine learning techniques. And the evaluation, which we have considered the metrics like precision, sensitivity, accuracy, and F score, which determines the best predictive models among all, as well as the modeling over here, as we have mentioned earlier. I have mentioned earlier that the machine learning algorithms have been used like decision tree, random forest, gradient boost tree, classifier, naive-bayes classifiers, as well as multi-layer perception neural networks, and many more. In this way, we have evaluated the performance and we have gone through several kind of recommendations of predicting which model is suitable and which has been given the best outcome. And coming to the result, in order to ensure that which machine learning model has given the best outcome, that is in terms of the accuracy, precision, and everything. These results which shows that which model has performed in which manner. While coming to the figure 2, which shows the initial screen where that which requires the Python and machine learning libraries that have been loaded successfully, and the figure 3, which displays the loaded data set. And moving on to the next result, that is figure 4, that which presents a bar chart that which illustrates the number of households with savings versus without savings. And our figure 5, which shows the pre-processing step, that is how the pre-processing has been done, and it is there any kind of missing entries are there. If so, we have replaced them by using the main value. And coming to the figure 6, that which illustrates the normalization of the dataset features using standard scalar to scale all values with a uniform range. And coming to the figure 7, that which shows the dataset has been being splitted into 80% of the data used for training and the 20% has been testing to evaluate the model. And coming to the next result, that which displays the definition of a function that which calculate the accuracy and other evaluation metrics of machine learning models. And our figure 9, which shows the training results by using certain models like Gini index, confusion matrix, and we have derived ROC curve and so on. Moving on to the next result, that is the figure 10, which presents the decision tree model that has been trained using information gain, along with which it has achieved accuracy and performance visualizations. And the other model, that is like a random forest model, that which we can observe in the figure 11, has been used. Over here we have used random forest in order to observe the accuracy as well as to evaluate the metrics. Moving on to the next result, that is the figure 12, which presents the random forest model trained using the information grain and displaying its accuracy and overall performance. And figure 13, which shows the training results based upon the naive-bayes classifier, and also it shows that how the metrics have been evaluated. And coming to the figure 14, that which displays the training outcomes of the MLP neural network classifier, showing its accuracy and performance metrics. And coming to the other result, that is figure 15, which shows the training results of the gradient boosting model, that which shows its accuracy and performance evaluation. Moving on to the next result, that is figure 16, which presents the training outcome of the extended ADA-boost classifier. This is the one which has achieved 100% accuracy along with the evaluation metrics. And figure 17 that which displays a comparison graph among the accuracy, precision, recall, FI score, which highlighting the extended ADA boost performance. And moving on to the next result, that is figure 18, which presents a performance comparison table that which summarizes the accuracy and evaluation metrics of all machine learning algorithms which we have used in our study. And figure 19, which shows the model using the algorithm to read the test data and get the record of each and every household of Malaysian people. And finally, the result, that is the figure 20, which displays the final output showing each test data entry along the predicted among the savings as well as non-savings. Moving on to the conclusion, I would like to conclude that we have utilized several types of machine learning models, and we have analyzed the data which has been applied very effectively to extract the meaningful insights from the COVID-19 household survey dataset. The methodology, that is the CRISP, which has guided the structured development of predictive models for assessing household financial alertness during the pandemic. As we have mentioned that we use some sort of machine learning models like decision trees, random forests, naive-Bayes, MLP neural networks, and a gradient boosted tree for evaluation purpose. It was observed that gradient boosted tree emerged as the best performing model, demonstrating the highest effectiveness in predicting financial alert households. The predictive model successfully identified financial vulnerabilities, proving that machine learning can reliably support crisis related economic analysis. And moving on to the references, we have considered only few references over here, but we have gone through a lot of references, so it is not possible to incorporate all those. So that's why we have considered over here only few references. The major, most important references that which we kept over here, and that's it. Thank you so much.